I guess draft science video. Don't know exactly what I'm going to mess with, but I guess some of it will be a little bit of this gravity wave stuff just to start. So I'll give you a link below to this Jesse Spouts. Anyway, it's just kind of irritating that all the people who say anything's wrong with, or anybody being a little bit cynical or a little bit critical, they all end up being flat Earth nuts or some other kind of kook. And a lot of these Tesla types, and so it is kind of funny. He's pooping on the gravity waves for a really dumb reason. I mean, it's a really dumb reason. 277 likes, 30 dislikes, 10,000 views, and you're just, I guess all I can say is I guess I'm being cranked. I mean, I'm being harassed by a higher quality of viewer that they don't fall for anything I say, kind of thing, like they do fall for this shit. I mean, I just can't imagine if I said something as dumb as this guy, what kind of crap I would be getting. So anyway, his problem with the thing is that there's 4 feet of Earth curvature that he said they somehow didn't account for, and it's just so silly. I mean, they spent $1 billion on this thing over the last 15 years or whatever. And you don't think they have like bulldozers that could just take out 4 feet of Earth over 2.5 miles? I mean, really, he looks at one picture and he says, "Oh, it's not high enough off the ground to compensate for the." Well, I'm sure there's places where the little hills are higher and the little hills are shorter. I'm sure they leveled about 30 or 40 feet, of ground, for that 2.5 miles. 4 feet, it's nothing. Curvature, it's the curvature of the Earth isn't an issue. I just, logically, you're just saying, how could you think they wouldn't know that their instrument has to be level for the pendulum mirror to work at all? I mean, first, the laser beam has to stay in the tube, and it wouldn't be staying in the tube if the tube was crooked. I mean, right there, it doesn't make any sense. What, you think they didn't figure that part out? I mean, come on. I mean, I don't want to give these people much credit, but, it's just such a silly thing to... I mean, quite obviously, I'm sure they excavated the land perfectly flat as they could possibly get it. And, and I'm sure in every process through the thing, they were shooting laser beams around everything to make sure they were as level as possible and all this kind of crap. So, I mean, and even if they ended up a little bit off, they just compensate like they did with the Hubble telescope being a little fucked up. You just compensate and just know that your beam is blah blah blah, so you just compensate for that much of crapola, and you just adjust the beam to compensate for the out of straightness. I'm sure they have a margin of error, that they do that with right now. I'm just saying that this is silly. This is silly. So anyway, I appreciate the link though. Somebody gave me a couple of these, but they're all Tesla people, and you're just like, oh fuck, this obsession with Tesla. I just don't get. I mean, even the other guy was playing the clip of the freaking camera guy with his freaking diffracto lens, whatever's Faro Shido thingo, whatever. It's quite obviously all the material is this ferro liquid, and what obviously is happening is when you put a magnet under it, the liquid gets really thick inside the 2 layers of glass where that is, and it's creating a distortion. It's bending the projection based on the fact that the absence it's creating a differential in pressure, and that's what's curving all the lines. But the lines would be straight if the thing was actually projecting accurately, and it's not. But, so because it makes pretty little lines, Tesla was right. Tesla was all about pretty lines. Just really silly. So anyway, but it is kind of annoying that, it just doesn't get all this. You didn't get any raggy comments, none of this bullshit. Not gratuitously insulted. It's just such a double standard on YouTube. It's hot in here. Should be kind of cold in here. Yeah, really hot. Anyway, so I was thinking about gravity, and And, I'm thinking about this whole idea of these two black holes moving half the speed of light just really bugs me. This whole matter moving these preposterous speeds just doesn't work in my brain at all. Just because all the radiation they're running into, we know how much. If an asteroid hit the Earth, and the asteroid was moving half the speed of light, how big would it have to be to fuck us up? To split the Earth in half, you know what I mean? It probably wouldn't have to be all that damn big, right? 100 feet across, maybe less, and it would make a decisive explosion. I mean, just decisively blow the Earth up. And it just seems like nothing's accounting for the fact that velocity and mass put together means that if you have an interaction between two things that have velocity and a lot of mass, that all that velocity has to turn into a balance somehow. Somehow you have to convert it into balance. And that's the real game. Like, how do you do that without liquefying the damn thing and basically starting over? So there's got to be some theory that these black holes somehow don't mind this interaction. This incredibly torque. The amount of torque. That somehow torque doesn't rip them to shreds. And I don't buy that. But anyway, I was thinking about how this whole, you don't get an image of how it actually happened, that these two black holes just happen to come into contact with each other and just happen to do this little swirly dance for a few milliseconds. And, at half the speed of light. Oh, please. So I was thinking about gravity. And I don't know if I need to draw a picture of it, but, gravity wells are just this gravity well thing, right? Okay, it goes down, goes back up. And the idea is if I move something just really slow, I just push it just a little bit, 2 miles an hour or something, just really slow, what it's going to do, no matter where I push it into a gravity well, it's going to go down and pop right back up and go 2 miles an hour on this side. I mean, theoretically, there's no way to create a retrograde orbit, if that's the right word, one that crashes into the sun as an orbit. There's no way to do it. There's anything you introduce with a velocity is just going to go down and pop back up the other side. So it's just going to go down, and it's like the reflection thing. It's going to go in at one angle, and it's going to pop out at exactly the opposite angle, the opposite direction, at exactly the same speed. That's what a gravity well is going to do. It's just basically going to convert, the movement. Unless the thing crashes into the sun, the thing in the middle. So it's either going to crash into it head on, or it's going to leave. But any foreign body heading for a gravitational well can't possibly get into a retrograde orbit. It has to either get into an orbit, or it fails. It either leaves, or it hits the sun. But it really can't do anything else, because theoretically it's going to pop out the other side. So the only way it cannot do that is it has to hit something as it's leaving. So it goes into the gravity well and then hits something as it's leaving and never gets to leave. And then it can get stuck in an orbit for a while. But theoretically, I think that's the only way you can create a retrograde or a degrading orbit, is that it has to hit something on the way out. That's really it. So I would like to see the math that justifies this, these two black holes somehow coming in contact with each other in some way that allowed them to do this spiral thing, where if the gravity is that intense, they'd crash really quick. And if they were going to get into this dance, the dance would be eccentrically uneven. They'd be processing. So their entanglement couldn't possibly be this thing they're describing, this circular spiral of these two things spinning at some sort of equidistant that just sort of degrades. They'd end up in something more eccentric, like something like this, where they would just wobble around each other in a in a mess, highly elliptical. orbit. So I don't think that's the way it happened. I don't think that's the way it happens. So it's got me thinking a little bit about galaxies, because they do have this distinctive feature of the armness, which implies that there's something, waiting. That it could be something imbalanced, that starts them off. Something, and there's images of this idea of galaxies that are almost two balls circling each other. They look like that anyway. But it makes me wonder that I think there has to be something in the middle. I think the only way you could have that happen is there has to be something in the middle, because that would be the only thing that could be doing the constant pulling. Because the other problem is, right, these two things, see, by their own description, they have this, I don't have the wave pattern here, but they have this wave, going, and then it goes at the end. Well, sorry, I'm out of picture. But anyway, so it's doing, so this part, somehow they're losing integrity enough to make this wave that we can detect. So this has to be burning some of those, those 3 suns worth of mass, 3 solar masses that are going to get burned away. But I was thinking about that, and I'm saying if it's just 2 things orbiting each other, that's a paradox of a sort, because as they're getting close and they're orbiting, and if they're starting to fall apart enough to create these gravity waves, that means they're losing mass. That means they're losing gravity. So as they're getting lighter as they're spinning. And I think that's a problem, right? I think if they're getting lighter as they're spinning, they're going to fly apart because they're not losing velocity. So they're losing the drag of mass, and they're retaining their velocity. I think that means, that they would have to start going further apart, not closer together. I think that's the only rational conclusion. I think. But this whole idea of creating this unlimited gravity supply, again, that's, I think, a real theoretical problem here. This idea of that gravity is an unlimited power source, that you can make the well as deep as deep as deep as deep, and so that you can make some kind of almost infinite well that something falls into, where it doesn't matter how light it gets, it's never going to get anywhere. It can't ever get released somehow. But like I said, no matter how light it gets, again, the well gets higher as it gets lighter, so it's easier to get escape velocity if you're getting lighter. Fact. The sun makes the gravity the Earth is in, and the Earth makes the gravity the sun is in. It's not the inverse, so it's really what your partner is doing in the gravity equation that decides where you're going. And if your partner's losing mass, that means your partner's losing gravity. That means you're more likely to leave town. I think that's reasonable. So anyway, I just see that's what's wrong with these illustrations they use with this bent, they bend a rubber drum, or they bend a fabric, and friction just fucks the whole game, because friction doesn't allow you to see what will really happen. Is if you throw something into the well, it's going to fly right the fuck out the other side. You're not going to be able to throw it in and make it orbit. You just can't theoretically do that. You just need to somehow throw it in and then have it hit something trying to go out. Somehow you have to create drag on the way out, or it ain't staying. So the dynamics are a little tricky. That's why that's why there's not so much shit, in the solar system. Is pretty much, I think, is because it either goes into the sun or it doesn't. But it's a little tricky getting caught in the gravity. Is to get caught, something needs to hit you on the way out. I think that's one of those things you might call a fact or a rule. Like Newton should have said, orbits are always ellipses. Not always, but they're generally speaking going to be, unless they're perfect. And the other fact should have been, hey, you can't get into one of these gravity wells without hitting something on the way out. If you go in and you don't hit the thing in the center, you don't go straight in and plow right into it, you're leaving just as fast as you came in, except you're just going to be going a different direction. Yeah, I think so. So maybe I'll just leave it at that. Why get into more complex things? But yeah, I got the electricity things, soon, and then the I think I want to talk a little more about velocity. And well, I guess I could do some of that really quick. I mean, it's just so obvious in some ways, that say you just have this spinning orbit thing, that defines the character of an atom, and you have these different pieces to this. Electrons are spinning, this is spinning, so it's more complex than this, but it's just this idea of you have a certain amount of stuff going down, you have a certain amount going up, you have a certain amount going this way, you have a certain amount going that way. And the argument I'm making is, as you acquire extra going this way, you release stuff going this way. So this goes in, this goes out. So this becomes your output, the equal but opposite reaction thing. And the real point is as you're moving now this way, you're going to encounter more arrows going this way. So the one you gave away, you're going to replace really easily because you're going to encounter more of those. So with velocity this way, the first thing that goes is these arrows, the ones going in the opposite direction of your velocity, obviously. And then the next, and then so that's no time dilation, right? Nothing's really changed up and down wise, so you haven't really lost any rotation. So that's why time dilation doesn't really kick in till you start hitting faster speeds. Because at faster speeds, what you start doing is you start killing these guys. And it's not like your orbit gets smaller. It's just that these are just not doing their thing as often. Okay, so because they're getting knocked out, because they have to be moved with the velocity, right? So they have to sort of get hit by an arrow, get exchanged for an arrow going in this direction, the direction of your velocity, and then they go back to being this for a while, and then they get knocked that way, and then they go back to being this. Because you have to move everything on the perpendicular, everything rotating perpendicular, this way, or this way, to your motion this way. Has to be essentially moved up there. It has to essentially be, altered to play along with the velocity. And, that's what's doing the time dilating, is the blinking out of the other dimensions. So they're not getting their orbiting done as quickly because they still have to do all the little steps, but they're getting knocked out of position, so it's like the dancing thing, they're having to keep stop dancing, move, stop dancing, move, stop dancing, move. So anyway, just wanted to throw that in. But the real key thing was just the obvious thing that the supply of these arrows going the opposite direction isn't going to be a problem, because the faster you're going, the easier they are to replace. And again, as I pointed out, the head-on collisions are meaningless, so it's all win. I mean, it's pretty obvious. So anyway. But, I got to do a more elaborate explanation of that, but I don't know if I have to, but I will when I get to it. See, this relates to electricity and this other stuff too, so. But all this stuff has, this whole, I don't know what to say. I just wish that the cranks were more, I wish they didn't do this. This is, I wouldn't even have critiqued this, but he did 2 videos, at least, maybe 3. Making the same stupid, they didn't account for the curvature of the earth. 3 videos, and nobody pointed out to him, you're an imbecile. Of course they flattened the 2-mile stretch to make it, my house there's 4 feet difference on the 2 sides of my house, for fuck's sake. Is my house crooked? No. Because they, the idiots were smart enough to say, oh yeah, you cut a little bit out over here, and you build it a little higher over there. No problem. The downside is it's, there's only a foot on, soil, crawl space under this side of the house, and there's like 3.5 feet in the back. So you can crawl under half the house, but you can't get under the part you need to, because that's the part more likely to rot, the part that's closer to the ground, right? So that's the little bit of a problem. So I have to do more excavating. But I don't like it under there. Yeah, I don't like climbing under rickety old cottages. But anyway, it's part of what. Until I win my Nobel Prize, I guess I can't hire some Mexican to do it, so I have to. Anyway, it's all very tragic. So yeah, that's all. I don't want to drag this one out. I just, like I said, I really am. Just so much rolling around. All these, the whole charge thing is just so fascinating because you can just see it. You can just see how, once you understand that these are all filters, and as soon as a piece of metal gets charged, it's basically turning into a polarized filter, but it's a really weak one because it's only polarized on the surface. Only the surfaces are polarized. So unlike a magnet where the whole thing is polarized all the way through, it's only the surfaces on charge. But it's doing exactly the same thing. It's sensitive to the one polarization and invisible to the other. And it's exactly the same mechanism as magnetism. It's just that it's so much weaker in a sense because the filter is just a thin layer of electrons on the surface. It is quite. I'm just finding that very interesting. The more you get into this, I mean, this new perspective just makes the whole subject of physics so much more interesting. So, I mean, I have to say that part is really quite enjoyable. Anyway, till next time and such.